Hello, I'm Kiran Kumar from Nature of Physics. Today topic is horizontal circular motion. O is the center of the circle, OX and OY in the plane, student. So this is taken as XY plane. So the particle is moving from A position to B position, C position and D position, student. The movement of an object in the circular path is called circular motion. So in which first point we are going to discuss radius vector, second one angular displacement, next angular velocity, after that angular acceleration, student. So the center to the position of the particle that represent the radius vector, that is line joining from the center of the circle to the position of the particle, and the vector drawn from the center of the circle to the position of the particle performing circular motion is also called a radius vector, student. Okay, r bar is the radius vector clearly represented in the diagram also. Next, angular displacement. Angular displacement nothing but the angle turned by the position vector with respect to center, student. That is taken as angular displacement. Angular displacement which is equal to arc length by radius. So theta is equal to AB according to the diagram, and theta is equal to AB divided by R, that is arc length by radius, student. And next, it is a scalar quantity because of large angles are scalar quantities, does not obey the law of vector addition, and theta SI units is a radian, student. And continuation, delta theta is the small angular displacement. Delta theta is equal BC by R. So according to the diagram, BC is the delta theta is the small angular displacement, that is arc length divided by radius. Delta theta is a vector quantity because of which obey the law of vector addition, student. For one rotation, theta is equal to pi, student. For one rotation, theta is equal to pi, and theta is equal to pi n representing for n number of rotations, student. And next one is angular velocity represented omega. The rate of change of angular displacement is called angular velocity. So omega is equal theta divided by t, student. SI units is writing now radian per second, student. And also dimensional formula writing no dimensional formula for the radian because of arc length divided by radius, meter per meter get cancelled. So L by L also get cancelled for dimensional formula. So 1 divided by t, student, or we can write t to the power of -1 is the dimensional formula for the angular velocity. Now omega instant writing, student. Omega instant is equal d theta divided by dt, student. And next writing omega average, student. Omega average is equal delta theta divided by delta t, student. Okay, and continuation here also we can write one more step. Omega average which is equal to delta theta is final angle theta 2 minus initial angle theta 1 divided by t2 minus t1, clearly represented in the diagram. See, student, A to C taken theta 1 and time taken t1, student. And A to D position time taken is theta 2, and also displacement, angular displacement is theta 2, student. So final displacement, angular displacement minus initial angular displacement divided by t2 minus t1, student. And also omega instant value writing like this: limit delta t tends to 0, delta theta divided by delta t, that value give the d theta divided by dt, student. Okay, with respect to limits, so average value convert into instantaneous value, student. And next one I'm going to discuss about the omega which is equal to theta divided by small t, student. I'm writing theta is equal to 2 pi and small t writing capital T, student. One complete rotation theta is equal to pi. For one complete rotation time taken is equal to capital T, time period, student. So here capital T is time period. So omega which is equal to 2 pi divided by capital T, students. Okay, and continuation, next mu represent the frequency, student. mu represent the frequency. Okay, so that omega, which is equal to 2 pi into mu, student. From the both equations, frequency is inversely proportional to the time period, student. Okay, and next one is angular acceleration, student. Angular acceleration represented by letter alpha, student. For angular acceleration, we are discussing the rate of change of angular velocity is called angular acceleration alpha, which is equal to omega divided by t, student. Okay, SI units of the omega, so that is radian per second, and denominator is second, so that SI units of the alpha value, which is we can write as radian per second square, student. Radian per second square. Okay, and continuation step, here we can discuss alpha instant value, alpha instant, which is equal to d omega by dt, student. Alpha average, which is equal to delta omega divided by delta t, student. Here also one more step we can write alpha average, which is equal to omega 2 minus omega 1 divided by t2 minus t1, student. Here alpha instant, which is equal to limit delta t tends to 0, delta omega divided by delta t, which is equal to d omega by dt. So with respect to limits, average value convert into instantaneous value, student. Okay, and next step is relation between them, so that the relation I'm writing first alpha, which is equal to d omega by dt, student, and next step alpha, which is equal to d omega by dt, and d theta multiplied and divided, student. Alpha, which is equal to d omega by d theta, next d theta divided by dt, student, and continuation alpha, which is equal to d omega by d theta into omega. Rate of change of angular displacement is called angular velocity, student. So alpha, which is equal to omega d omega divided by d theta, student. This is the relation between the angular acceleration and angular velocity, student. Okay, so we can represent the equations. This is I'm writing equation number 1, student, and cross multiplication also we can write alpha into delta theta, which is equal to omega into d omega, student. Okay, integration on both sides, alpha into d theta, which is equal to integral omega into d omega, student. This is clear information about the horizontal circular motion, radius vector, angular displacement, angular velocity, and angular acceleration. Please do like and subscribe our channel Nature of Physics.